Hello guys, welcome back to the video. Today we are going to see problem number 326, that is power of 3. So it's an easy problem and I'm going to make it more easy for you guys. So given an integer n, return true if it is a power of 3, otherwise return false. An integer n is a power of 3 if there exists an integer x such that x equal to 3 raised to x. So don't you think it's quite similar to the power of 2 problem that we solved couple of days back? Yeah, only in this case, like the previous case it was 2 and here it is 3. Okay, so let's take an example and see, like n equal to 27 and we know like 3 raised to 3 is 27, 3 cube is 27. The next example is 3 raised to 0. Obviously we're returning a false because there is no number raised to 3. We'll get a 0 and minus 1, again a negative number. Let's see the constraint. The constraint are minus 2 raised to 31 and 2 raised to 31 minus 1, that is an integer value. And one follow-up is also given. Could you please solve it without loops and recursion? Okay, we'll try to do that. Okay, I'll take my pen and get started. So we'll write the some starting range of power of 3. Okay, like 3 raised to 0. Okay, 3 raised to 1. This is 1. This is 3. 3 raised to 2. This 9. 3, that is 27. 3 raised to 4, that is 81, and 3 raised to 5, that is will be 243. Okay, so this is the range, so we have to find if n lies in this range. Okay, so let's take an example, like I took 81. Okay, 81. So if we divide it by 3, okay, we are getting 27. Okay, then again if we take 27 divided by 3, then we are getting 9. And similarly, if we keep on doing it, like 9 by 3 will get 3, and lastly 3 by 3 will get a 1. So you see I just divided by 3 because it's multiples, means 3 raised to x, correct? So we are only multiplying to generate them by 3. Okay, so I'm just keep on dividing it, and if I'm getting 1, I can say it is a power of 3, because I can reproduce it by multiplying by 3 and get it. I can get 1 by dividing by 3 continuously. So if we take another number like 6, okay, 6 is also divisible by 3. So let's try for 6. 6 by 3, what it will be? It will be 2, and 2 is not further divided by 3. Okay, so it's not a power of 2. So we got it one logic, like how to build up, how to get like it's a power of 2 or not. We'll just write a loop for it and we'll get it. So let's do it. So we'll take one uh, while, okay, while n by 3 is equal to 0, we'll be doing n equal to n by 3. And if we'll return n is equal to 1, correct? That only we are doing. We are taking the n, we are dividing, means we'll see if it's divisible by 3. If it's not divisible, we'll directly returning false. Okay, and if it's divisible, we will keep on dividing it by 3. So I'll just run the code and let's see. Okay, so we got a time limit exceeded for 0. Okay, yeah, got it. So for this, if n is less than equal to 0, we have to directly return false, where we'll not be getting it, right? False. We'll not go into this loop because when n is 0, we know that what is the answer and we'll returning directly false. Because power of 3 will be always in positive side. Yeah, we're getting our answer. We'll submit it. Okay. So we have solved this successfully, and the time complexity for this will be log of n, because we are just dividing the n number with 3 till we are getting a 1. Okay. So if we go to problem back, there is a follow-up. Could you please solve it without loops and recursion? So let's see how can you solve it. For that, I've opened a compiler here and I've run a query. So don't worry, I will explain about it. So I've taken a count, a current, and the maximum integer value that we can have. And I'm running a loop where current is greater than 0 and current is less than max. So we need to find like what is the maximum value of power of 3 we can get in the integer form. Okay, for that only I'm keeping the current value is power of 3. We are just multiplying it with 3. Okay, and we are seeing, I'll just run it and show you guys. Okay, so here we are getting like 3 and its power like 1, like 3 raised to 2 is 9, 3 raised to 3 is 27, 3 raised to 4 is 81. Similarly, we go down, we will see one minus value, so that is that it is overflowing from the integer, correct? So 3 raised to 19 is the maximum value that we can get here. So you must be thinking what to do with these values, correct? So what my observation here is, this is the highest number, right? And if we take any lower number or number itself, it can completely divide this number, right? So I will show you, we'll do it here. So I've taken this number here and I've taken a smaller number, and let's see what's the value we are getting. We are getting a 0. So it's completely divisible. So it's a range first thing, and we are getting this range by doing a power of 3 only. So any number in this can divide completely the other bigger number. That's my logic, and that's we are going to use it here. So we'll try another example. Before that, we'll take this one. Okay, I'm taking the highest number, that is 3 raised to 19, and dividing it with 3 raised to 17, and let's see what happens. So this is the thing, it will not completely directly stuck in your mind, but if you try to play with the things, you will get it. Okay, so again we are getting a 0. So we'll try to write a code for it. Okay, so first thing, int max equal to, we'll just take that value, that is 3 into 3 raised to 19. Okay, and we'll return if n is greater than 0. Yeah, this we saw in the previous example, correct? And max divided by n is equal to 0. Correct, it should be equal to 0. I'm going to try to run it. Okay, oh, okay, I need to put a bracket here. Not equal to, it should be greater. Yeah, it's working. Let's see. Okay, yeah, that is working completely fine. So, and this for this the complexity is 1, and whatever they have asked us to do without a loop, we have done it successfully. So thank you for watching the video. If you have any doubt, please comment down. I'll try to help you. Please subscribe the channel and keep watching for such more videos. Thank you.